All right, welcome to the deep dive. Today, we're going to be diving into a really foundational framework, I think, for thinking about decisions, especially decisions when things aren't certain. We never know for sure what the future holds, and this framework is called expected utility theory. And knowing our listener, you're coming at this with a philosopher's toolkit, a philosopher's lens. So we're going to be looking at it through that particularly philosophical lens today.
That's a great way to put it. Yeah, we're not just going to describe, how people do make choices, in the face of uncertainty, but to really get into those normative questions, the should questions, the how should they choose questions.
Yeah, those are always the juicy ones.
Exactly. So our mission, I think, for this deep dive is to really try to unpack, what is this idea of expected utility theory? Why is it so important? And then get into some of the philosophical debates that have really sprung up around it. And our main resource for this is going to be the Stanford Encyclopedia of Philosophy. They have a really good entry on expected utility.
Yeah, GCP, always a good resource. Expected utility. Right? It might sound a bit academic at first, but actually the underlying idea is something we all grapple with constantly, like all the time. Think about this, you're heading out and the weather's iffy. You've got that classic dilemma. Do I grab my umbrella or do I leave it behind? And with each choice, it could lead to different outcomes. It depends on what the state of the world is, whether it rains or not. And you've got preferences, I'm sure, for each of those. Like staying dry and not having to carry an umbrella is ideal. Staying dry but having to just let the umbrella around is fun. But then, of course, getting soaked, that's probably not your favourite.
Right. Yeah, I think that's such a good illustration. Expected utility theory basically takes these kinds of situations that we face all the time, everyday situations, and tries to formalize them, right? So it really tries to pinpoint these three key elements. There's the outcome, right? That's what you were talking about. The things you ultimately care about, right? Am I dry? Am I wet? What's the state of me when I get to where I'm going?
Right.
And then there are the states, the factors outside your control, right? You can't control the weather, so whether or not it rains is a state.
Right.
And then importantly, there are the acts. These are the choices that you make. So do I take the umbrella or do I leave it behind?
Right.
And expected utility theory basically gives us a method to rank these different actions that we can take based on how much we value or how much we prefer different outcomes, and then also taking into account how likely those outcomes are, right? Combines those two things.
Right. That makes sense. So how do we actually, put a number on this? I mean, is there like a formula? Is there an equation? I mean, I know there's math involved, but
right.
how do we assign these numbers, this expected utility?
Yeah, you're right. There's definitely math. But the math is not as scary as it might sound.
Mm-hmm.
So the basic formula is this. And it looks a little complicated when you first see it, but it's actually pretty straightforward. So it's EU in parentheses A equals, and then you have the summation sign, big sigma, and then you have little o, that's an outcome, element of big O. That's the set of all possible outcomes. So you're summing over all the outcomes. And then inside the summation, you have PA in parentheses O. So that's the probability of outcome O, given that you take act A times U in parentheses O, which is the utility of that outcome. So essentially, like I was saying, you take each possible outcome, you figure out what's its utility, how much do I like it or dislike it. Then you say, how likely is it to occur if I do a particular action?
Okay.
You multiply those two things together, and then you just add all those up for all the outcomes.
Okay, so that makes sense. It's kind of you're weighting each outcome by how good it is and how likely it is.
Yeah.
Adding them up.
Exactly.
Okay, so utility, that seems pretty personal, right? Is all about money.
That's such a good question, and I think that's a critical question when you start thinking about the philosophical implications of expected utility theory. Sometimes we equate utility with money, especially in economics, how much money will I gain or lose. But the theory itself actually acknowledges that, what we value can be much broader than just money, and it can be very idiosyncratic. So think back to Bernoulli, the mathematician. He made this really interesting observation that, the same amount of money can have a totally different impact on someone who is very wealthy versus someone who has very little.
Yeah, that makes sense.
Right. That's the idea of diminishing marginal utility.
Right.
If I give you $1 and you have $1 billion, it's not going to make a big difference to you. But if I give $1 to someone who's struggling to put food on the table, that dollar has much, much more value.
Right. It's the difference between, winning $1 million if you're like most people, that's like life-changing. But if you're, a billionaire, like you said, it's probably just a rounding error. It's not going to even really affect you.
Yeah, exactly.
Love it.
And when we get into the philosophical nature of utility, there are different schools of thought. Like the classical utilitarians, like Bentham and Mill, they thought of utility as a measure of pleasure or happiness. How much happiness is going to be produced by this outcome?
Right.
But contemporary decision theorists often see it more simply as a reflection of preferences. If you prefer outcome A to outcome B, then A just has higher utility for you. That's all. And then there's this other view, and this is defended by a philosopher named Broom, who argues that utility could even represent, like, objective betterness, what a fully rational person would prefer.
Interesting.
Right.
So it's not even necessarily about what you currently want or desire or how much happiness would bring you. It's like, what should you want? What should you value?
Right.
Wow. Okay.
And that brings up all these thorny metaphysical issues about interpersonal comparisons of utility. Like, if my utility of 10 and your utility of 10 are based on our totally different subjective preferences, are they really equivalent in some objective sense?
Right. Yeah, that seems like a whole other deep dive we could go into.
Oh, yeah.
Definitely.
Yeah.
Okay, so utility is like the what we desire part, the what we value part.
Mm-hmm.
What about the PA, parentheses A part, the probability of the outcome given the act? It seems like that could be viewed in different ways too, right? Especially from a philosophical perspective, from like an epistemological perspective.
Totally.
Yeah.
Yeah. The interpretation of probability is another area where there's a lot of philosophical discussion around expected utility theory. So one way to think about probability is just as a measure of your subjective degree of belief. So how confident are you that a particular outcome is going to occur? So, in our umbrella example, your PA of rain, might be based on how you interpret the weather forecast, or just your general sense of like, oh yeah, it feels like a rainy day. It just seems likely.
Right. Right.
But we could also think of probabilities as objective chances. The actual likelihood of an event happening in the world independently of what anyone believes.
Okay.
Or, and this is more of a normative take on probability, we could think of them as warranted degrees of belief. So not necessarily what you currently believe, but what you should believe given the evidence.
Okay, so depending on how we interpret this probability part, whether it's what we think, what's actually out there, or what we should believe, the best course of action, according to expected utility theory, might actually change, right?
Absolutely. Yeah, it could definitely change. And then there's this other wrinkle. You said the probability of the outcome, given that you choose Act A.
Right.
And that phrase, given that you choose Act A, really gets to the heart of this really interesting distinction between two different versions of decision theory: evidential decision theory and causal decision theory.
Okay, well, I'm all ears.
So evidential decision theory, this is most closely associated with a philosopher named Richard Jeffrey. And he says that the relevant probability is the conditional probability of the outcome given the act. So it's P, parentheses, O, given A. It's a conditional probability. And the idea here is that choosing a particular action sort of tells you something or suggests something about the likelihood of the different outcomes. So let me give you let me give a concrete example. Like, imagine you see someone walking down the street and they look really sad.
Okay.
Right? Like, evidential decision theory might say, okay, well, them looking sad, that's evidence that they're having a bad day.
Right.
So if you go up to them and offer them, I don't know, some ice cream, let's say that's your act,
Yeah.
the probability of them cheering up, that's the outcome. That's linked to that evidence that you saw.
Yeah. Yeah. I guess if you saw a bunch of people walking down the street carrying umbrellas, you'd say, okay, well, that's evidence that it's probably raining, and so my probability of getting wet, given that I don't take an umbrella, would increase.
Yeah, exactly. Exactly. So you're sort of updating your beliefs about the world based on what you see. But this approach can lead to some counterintuitive conclusions. And the most famous example of this is a thought experiment called the Newcomb problem.
Okay, I've heard of this.
Yeah.
It's a bit of a brain twister.
Yeah, it definitely is. So the Newcomb problem basically involves the scenario where there's a predictor, like a super intelligent predictor.
Okay.
And they're really, really good at predicting what people are going to do.
Okay.
And they present you with two boxes. There's a closed box and there's an open box. The open box has $1,000 in it.
Okay.
And the closed box, the predictor has either put $1 million in it or nothing. And they've done this based on whether they predicted you would take only the closed box, what's called the one box option, or whether they predicted you would take both boxes, the two box option. So if they predicted you would be greedy and take both boxes, they put nothing in the closed box. But if they predicted you would just take the one box, they put $1 million in it.
Okay, yeah, this is where it gets tricky.
Yeah, it definitely is.
Because just from like a purely monetary perspective, taking both boxes seems like it always gives you more money.
Yes.
Really
Good
do.
think, right.
Yeah.
Yeah. So like you said, two boxing seems to dominate. Like no matter what's in the closed box, you're going to get at least $1,000 more if you take both boxes.
Right.
But evidential decision theory might actually recommend that you only take the one box, because choosing to one box is seen as strong evidence that the predictor anticipated that you would do that and therefore put the $1 million in the closed box. Right. It's like the predictor's so good, the fact that you're even thinking about one boxing suggests that they already knew you would one box.
Yeah. And that they put the $1 million in there.
Yeah.
Wow. This really makes you think about the relationship between correlation and causation.
Yeah.
Right? Because my choice to take one or two boxes isn't actually causing the money to be there or not.
Right. Yeah. That's exactly right.
It's already been decided.
Right. It's already been decided. And that's where causal decision theory comes in.
Okay, so how does causal decision theory try to like resolve this?
So causal decision theory, which is really championed by Savage, says, look, the important thing is the causal connection between your actions and the outcomes. So, in the Newcomb problem, a causal decision theorist would say your choice to take one box or two boxes can't actually causally influence what the predictor has already done.
Right.
Right.
Yeah, that makes sense.
Yeah. So since two boxing always gets you more money no matter what,
yeah,
it's the causally rational choice.
Okay, so it sounds like a pretty subtle but really important distinction in how we think about like agency, right?
Yeah, absolutely. Like what can you actually control?
Right.
What's the causal impact of your choices?
Yeah. Okay.
And it's worth pointing out that, even if we agree on the ranking of the outcomes, like we all agree that this outcome is better than this outcome, the actual numbers, the specific numerical utility values we assign to them, can actually change what expected utility theory recommends.
Okay, so it's not just about the order. It's about how much more we value one versus the other.
Exactly. So think back to, our umbrella example. We said being free and dry is the best, encumbered and dry is the middle, and being wet is the worst. But just changing those numbers we assign to each outcome, making them further apart, closer together, could actually flip the advice.
Interesting.
Right. So even if we all agree on the ranking, just the numerical values can affect what the theory tells us to do.
Okay, so that's really highlighting the importance of the utility function. And I guess this idea that only certain kinds of transformations of the utility function are allowed, right?
Right. And that's this concept of positive linear transformation. So the idea is that, you can multiply all your utility values by a positive constant, or you can add a constant to them.
Okay.
But that's it.
Okay.
And those are the only kinds of transformations that are allowed, because those preserve the underlying preference order.
Right. So like if I prefer A to B and I multiply all my utility values by 2, I still prefer A to B.
Exactly.
Yeah.
It's like converting Celsius to Fahrenheit.
Yeah, you're just changing the scale.
Yeah, you're just changing the scale, but the underlying temperature is the same.
Mm-hmm.
And that's what positive linear transformations do to the utility function.
Right. Okay. So we've got a pretty good understanding, I think, now of what expected utility theory is. Now let's turn to this question of like why should we as rational agents aim to maximize expected utility? What's the philosophical justification for this?
Right. That's the $1 million question.
Exactly. No pun intended with our Newcomb problem example.
Right. Exactly.
So what are the core arguments in its favor, especially from a philosophical perspective?
So there are two main types of arguments. The first are what are called long-run arguments.
Okay.
And these basically draw on some fundamental statistical principles, the law of large numbers.
Go ahead.
So there's a weak law of large numbers, there's a strong law of large numbers. But basically, the idea is if you consistently make decisions that maximize expected utility across a large number of similar independent situations, then with a very high probability, your average utility gained per decision is going to approach the expected value of a single decision.
Okay, so if I'm playing a game where every time I play, I have a slightly positive expected utility.
Yep.
If I play it 1 million times, I'm very likely to come out ahead.
Exactly. That's the idea.
Okay.
Yeah, you're going to win more than you lose. And so in the long run, you're going to end up with more utility. So that's the basic intuition. And the laws of large numbers really do suggest that, this is going to happen. However, there are some big limitations to this argument, especially for someone thinking about, individual rational choices. Like, a lot of the most important decisions we make in life, right? Career decisions, who to marry. These kinds of fundamental life choices are not things you do over and over again.
Right. You don't get a million do-overs.
Exactly. So how relevant is this long-run argument to those kinds of situations?
Yeah.
And also, these long-run arguments often depend on this assumption of independence, that the different choices you make, they're all independent of each other. Like flipping a coin, each flip is independent. But a lot of times that's not true, right? Like medical treatments, for example.
Right. The outcome of one treatment could affect the outcome of the next treatment.
Exactly. So there are lots of situations where these assumptions just don't hold. And then finally, even if the probability is really, really high, like approaching 1, the law of large numbers doesn't give you a guarantee.
Right. It is not a certainty.
It's not a certainty.
Right.
It's always possible, even if it's incredibly unlikely, that the average utility could deviate from the expected utility.
Okay. So these long-run arguments, it seems like they're kind of limited, at least from a philosophical perspective, when we're thinking about individual choices.
Yeah.
What's the other main kind of argument?
The second type of argument is based on what are called representation theorems.
Representation theorems. Okay.
Yeah. So these are basically mathematical proofs. And they try to show that if your preferences satisfy a certain set of axioms, which seem plausible, like axioms of rationality, then your preferences can be mathematically represented as if you were maximizing expected utility.
Interesting.
So it's basically saying, look, if you're rational, your choices should have a certain structure, and that structure can be captured by this mathematical framework of expected utilities.
Okay,
yeah.
right.
And so a typical representation theorem argument has these 3 components. So there's a rationality condition,
Okay.
which says that the axioms of expected utility theory, these axioms we've been talking about, these are actually the fundamental axioms of rational preference.
Yeah.
So if you violate these, you're irrational. That's what it's claiming. Then there's the representability part, which is basically the mathematical proof. It says if your preferences obey those axioms, they can be represented by probabilities and utilities. And then there's this really crucial third part called the reality condition, which claims that if your preferences can be represented this way with probabilities and utilities, then you actually have degrees of belief, you have preferences that really correspond to those.
Okay.
And this reality condition is really where the philosophical debate is.
Right.
Because the first part, the representability part, that's just math.
Right.
like, can we find numbers? Can we find a probability function and a utility function that fit the preferences? But the reality condition is saying, well, do those numbers, do they actually reflect what's going on in the person's head?
Right. Because it seems like, just because I can, describe some phenomenon using a mathematical model doesn't mean that the underlying reality perfectly mirrors that model, right? Like it's just a model.
Exactly. And as our source points out, it's conceivable that you could represent those same preferences, those same observed choices using a totally different framework, maybe one that doesn't involve probabilities at all. Right. So why should we privilege the expected utility representation? Why should we say, oh, that's the real one, that's the one that captures how people are really thinking?
Right.
And there are arguments that people give, like they say, well, having preferences that align with these axioms, it leads to more coherent and predictable choices.
Really?
But other people say, well, maybe our intuitive notions of belief and desire, don't map perfectly onto these really precise mathematical constructs of probability and utility.
Right.
So it's a very, very active debate.
Yeah. Okay. So these representation theorems, they show this mathematical connection between certain preferences and maximizing expected utility, but they don't really justify it, at least not without these extra philosophical assumptions.
Yeah.
Right. About rationality and whether the model really reflects how we think.
That's a great way to put it. Yeah.
Okay, so our source goes on to talk about some really influential representation theorems, each of which kind of has its own approach, its own focus. And they talk about Ramsey's work, which was really foundational, and he was trying to define both probability and utility at the same time from these preferences over gambles.
Yeah, and he uses this idea of what he calls an ethically neutral proposition.
Okay.
Which is, it's kind of like an anchor, right? It's like a proposition that we can all agree on that doesn't have any sort of moral baggage to it.
Okay.
And then he tries to build up both probability and utility from there.
Interesting.
Yeah. Then von Neumann and Morgenstern, they focused on preferences over lotteries.
Oh.
So they kind of assumed that probabilities were already well-defined. Like, if you have a fair coin, there's a 50-50 chance it's going to land on heads, that kind of thing.
Okay.
And then they tried to figure out, okay, what utility function can we derive, that fits with those probabilities and with the person's preferences. And then Savage had a different approach. He started with preferences over actions or acts.
Okay.
And then he derived subjective probabilities from those preferences.
Interesting. So it's kind of like the reverse.
Yeah, it's kind of the reverse.
Right.
Yeah. And then he ended up with a unique probability function and a utility function.
Right.
But his approach really requires some very strong assumptions about, how rich and how structured the space of possible actions is.
Okay.
Yeah. And then there's Bolker and Jeffrey.
Okay.
They looked at preferences over propositions. So the idea here is that a proposition can have both a utility, like, how much you care about it being true,
Right.
and a probability, like how likely you think it is to be true.
Okay, so it's combining those two.
Yeah, it's combining them, and their representation ends up with probability and utility being jointly derived, but they're only unique up to a fractional linear transformation, which is a bit more complicated. But later on, a philosopher named Joyce modified their approach, and he was able to get a unique probability and a utility that's unique up to a positive linear transformation by introducing this primitive relation of more likely than.
Okay. Yeah, and the source has a nice table that kind of summarizes all the key differences between these different representation theorems.
Yeah.
So you can kind of see, what's the basic object they're starting with.
Yeah.
What order do they build up the probabilities and utilities,
Right.
and what's the level of uniqueness they're able to achieve.
Right.
And what's really interesting is that, the order isn't even consistent across these different theorems.
Right.
So like sometimes utility helps to define probability, sometimes it's the other way around.
Yeah.
So it seems like, I don't know, this is really more about like mathematical relationships, not necessarily reflecting some kind of like fundamental metaphysical or psychological dependence between these concepts.
Yeah. Yeah, I think that's a good observation.
Okay. So we've talked about the arguments in favor of expected utility theory, and they're mathematically elegant.
Right.
But they also come with these philosophical caveats. Now let's turn to the criticisms. A theory as influential as this must have faced some serious objections.
Oh, definitely. And there are some pretty compelling ones. So
Okay.
so I think we can organize them into a few categories. So
Yeah.
so first there's this argument that maximizing expected utility is impossible.
Impossible.
At
Yeah.
least for beings like us, with our limited cognitive abilities. So, thinkers like March and Simon, they pointed out the just huge computational demands of this theory. Like, you would need to perfectly understand all the possible actions, all the possible outcomes, and all the precise values. And that's just, who can do that?
Right. Yeah, and Lindblom, he talked about muddling through.
Right.
Right.
Yeah.
Where we're not engaging in this totally rational, comprehensive calculation all the time.
We're kind of feeling our way through.
Right.
And then there's McGee.
Okay.
He made this even more radical argument. He said it might actually be mathematically impossible, even for an ideal computer, to perfectly maximize expected utility because of these fundamental limitations in formal systems
Okay.
related to like the undecidability of arithmetic. Like
Right.
to actually perfectly apply expected utility theory in all cases, you might need to determine the truth value of every single arithmetic statement, and that's just not possible.
So the theory is kind of like this ideal of rationality.
Yeah.
That's maybe not attainable in practice.
Yeah.
Or even in principle.
Yeah, it's a goal to strive for, but maybe we can never actually get there.
Okay.
And then people have responded to this in different ways. So there's this idea of bounded rationality, which says, look, we should just try to make good enough decisions. We don't have to be perfect maximizers.
Hey.
And then there's also this philosophical debate about whether ought implies can. Like, just because we can't perfectly maximize expected utility, does that mean we shouldn't even try?
Right, right.
Yeah.
So maybe it's impossible to perfectly implement it, but is it still rational to try to approximate it as best as we can?
Yeah, that's a good question. And then the second major category of objection says, well, actually, sometimes maximizing expected utility is just irrational. Like, it leads to outcomes that seem crazy, and this is where all the famous paradoxes and counterexamples come in.
Right, the fun part. Okay, so let's dive into those.
Yeah. So we've got counterexamples that challenge these basic axioms of expected utility theory, like transitivity.
Okay.
You know, if I prefer A to B and B to C, then I should prefer A to C. That's transitivity.
Right.
And then completeness. The idea that I can always rank any two options.
Okay.
So there's this really cool thought experiment called the self-torturer problem.
Okay.
And this was proposed by a philosopher named Quinn. And basically the scenario is that you're offered a sequence of choices. And each choice involves getting a slightly less painful electric shock in exchange for a large sum of money.
Okay.
And so you might think, well, yeah, I'll take that deal. A little bit of pain for a lot of money, that's fine.
Yeah, sure.
But the problem is, as you go down this sequence of choices, you eventually end up in the situation where you're choosing to endure this like really agonizing level of pain in exchange for a vast fortune over the option of having no pain and a slightly smaller fortune.
Okay.
Right.
So each individual step seems rational, but the end result seems crazy.
Exactly.
Yeah.
Exactly. And so it suggests that maybe transitivity doesn't always hold.
Right.
Like each individual choice seems fine, but the overall preference that emerges seems irrational.
Okay.
And then there are also cases of incomplete preferences. Like imagine someone who's trying to decide on a career. You know, maybe they're trying to decide between being a professional singer or being